Good afternoon, sir.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon all. We are going to revise acids, bases, and salts. Right.
Sir,
So here we have
it's a
yeah.
physics class, no, sir?
That is the cancelled class was for physics or chemistry.
Okay, sir.
I think the cancelled class was for physics.
Good afternoon, sir.
Good afternoon. Good afternoon. So let's continue. मेरा phone दे मेरा phone. Class cancel कर दिया. Okay, so see, we are going to revise chapter acids, bases, and salt. So just from beginning, I'm going to quickly review everything from acid, bases, and salts, and then we'll be doing these questions which are based on that. Okay, so see, for acids, bases, and salts, we had defined the substances as acids. So which substances are called as acids? Yes, come on quickly. Be quick in responding. Which substances are called as
Acids are sour in taste.
Sir,
acids?
acids are those which possess H plus ions.
Okay, acids are not, they do not possess, they liberate H plus ions in their aqueous solution.
Their pH is less than 7.
Yeah. So they give H plus ions in their aqueous solution. However, we say H plus ion, but the solution doesn't necessarily contain H plus ion. Okay, like if we are taking HCl in water, so HCl in water, it will contain this first of all your HCl. So this HCl will break down to give H plus and Cl minus, and water will also dissociate to give H plus and OH minus. Got it? So in this solution of HCl and water, we have ions of H plus also, we have ions of chloride also, we have ions of hydroxide also. But out of these, if I say the concentration of H plus ions is more, since the H plus ions, they are obtained from HCl as well as water. So the concentration of H plus ions is more, and hence the solution is acidic. HCl cannot liberate H plus ions without the presence of water. If I say suppose HCl is there and HCl liberate out H plus ions without water, so that is not possible. So HCl or any acid or any base or any salt can liberate out ions only in presence of water. So acids are the substances that give H plus ions in aqueous solution. In the same way, we define bases. So bases are the substances which give hydroxide ions. But as per the Arrhenius concept, if I go, so as per the Arrhenius concept, bases are the substances that accept H plus ion. Here we study that bases are the substances which give hydroxide ions and acids are the substances which give H plus ions in their aqueous solutions. Right. Then we had studied about some mineral acids and organic acids. So what are organic acids and what are mineral acids? Yeah, what are mineral acids? Yes, can anyone answer what are mineral acids and what are organic acids?
Sir, mineral acids are inorganic acids or acids that we make in lab. Organic acids are found naturally.
Yeah. So organic acids, they are formed naturally in living organisms. Organic acids, they are obtained from the living organism, whereas mineral acids, they can be formed in laboratory. For example, you have hydrochloric acid, nitric acid, sulfuric acid, carbonic acid, H2CO3, carbonic acid, sulfurous acid, H3S, H2SO3. This is sulfurous acid. So all these acids, they are mineral acids. Whereas organic acids are the acids which are found in living beings or obtained from the living organisms. For example, citric acid, tartaric acid, malic acid, tannic acid. So these are different examples of organic acids which are obtained from living organisms. Got it? So you have mineral acids and organic acid. Now, strength of an acid or a base. So strength of acid is measured with the help of pH. Strength of an acid, it is measured with pH or potence. So pH or potence, it depends on the concentration of hydrogen ions and it is the negative logarithm of, define it as negative logarithm of hydrogen ion concentration. So the negative logarithm of hydrogen ion concentration is called as pH of the solution. So greater the amount of hydrogen ions, always remember, this is a key point for the questions relating to pH. So if you have a high pH means low H plus ion concentration. It means low hydrogen ions. And if you have a low pH, so low pH means you have high concentration of H plus ion. Since the concentration of H plus ions determine the acidic strength, so it has a low H plus ion, it will be less acidic. And the ones which have low pH, so they will be highly acidic. Then we studied about the reaction between acid and bases. So if an acid reacts with base, the reaction of an acid with base will give salt and water. So this gives us salt and water. But a reaction with of an acid and base it gives salt and water. This is also called as a neutralization reaction. This reaction is called neutralization reaction. We have also seen the reaction of acids with metal. So acid with metal, it gives salt plus hydrogen gas. The reaction of acid with metal oxide, The reaction of acid with metal oxide, it gives salt plus water. The reaction of acid with metal carbonates, acid with metal carbonate, it gives salt plus water plus carbon dioxide. Since it's a carbonate, so there is evolution of carbon dioxide gas when an acid reacts with metal carbonate. Also, if an acid reacts with a metal hydrogen carbonate, if it reacts with metal hydrogen carbonate, so then also we obtain salt plus water plus carbon dioxide. Only in a few cases, like here, most of the metals they liberate hydrogen gas. Those metals which are highly reactive, they do not liberate hydrogen. Got it? Like nitric acid or even the metals which are highly reactive, they also do not liberate hydrogen gas because the hydrogen gas that is produced, it catches fire and oxidizes to water. Right? Then we have seen here pH of soil. The pH of soil, which should be neutral in nature. We see pH as a cause for tooth decay. We observe pH in our everyday life, that is in our stomach. The pH is acidic, where we use so here in for the neutralization of the acid in pH, we use some other substances like milk of magnesia and other antacids can be used for oxidizing the for neutralizing the acidic nature. Okay. Then after that we observe some salts from chemicals from common salt. Chemicals from common salt. Chemicals from common salt. So we observed that from common salt we obtain three important chemicals: hydrogen, chlorine, and sodium hydroxide. So these are the three important chemicals which we obtain from common salt. Okay. Then other chemicals which we have studied in this whole chapter. In this chapter, we have studied about 4 chemicals. We studied washing soda with chemical formula Na2CO3.10H2. We have studied baking soda with chemical formula NaHCO3. Then we studied bleaching powder. So bleaching powder has the chemical formula CaOCl2, calcium oxychloride. The last chemical we studied was POP or plaster of Paris. So POP or plaster of Paris, its chemical formula is CaSO4 dot half H2O. So along with their chemical formula, we should also know their common names, chemical names, and their manufacturing process. For example, for the manufacturing of washing soda. If I want to manufacture washing soda, so what washing soda can be manufactured from? To manufacture washing soda, we use ammonia, carbon dioxide. We use ammonia, carbon dioxide, and water. Okay, what other thing is used here? We use
HCl.
HCl or NaCl. What do we use?
NaCl.
NaCl. So we use here NaCl. So from there we obtain NaHCO3 washing soda, uh, NaHCO3 baking soda, and we obtain NH4Cl ammonium chloride. Now this NHCO3 can be heated up to obtain washing soda, which can be crystallized to washing soda. NHCO3 will be heated to form sodium carbonate, and then sodium carbonate can be crystallized to Na2CO3.10H2. Okay. So this was the manufacture for both of them, washing soda and baking soda. Bleaching powder is manufactured by passing chlorine gas through slaked lime. So if you pass chlorine gas through slaked lime, calcium hydroxide, you obtain bleaching powder. POP is calcium sulfate hemihydrate, which is CaSO4.12H2. So it is obtained by heating gypsum. So I think this is what revision was required from this chapter. Is there anything else which anyone wants to know from this chapter? Because now we'll be moving on to the question answer for the review. Yes? Anything? Okay, let's see the questions which we can do. So for your first question is, name the natural source of each of the following acid. The first one is citric acid. So what is the natural source for citric acid? From
Lemon.
where do we? Lemon. All the citrus fruits. So we obtain the citric acid from all the citrus fruits. Okay. Lemon. Oxalic acid.
Tomato.
Tomato. Very good. Lactic acid.
Curd.
Curd. And tartaric acid. From where do we obtain tartaric acid?
Baking soda, sir.
Baking soda. No. Baking soda.
Tamarind.
Tamarind. Yes. So tamarind is the natural source for tartaric acid. Okay. A student detected the pH of 4 unknown solutions A, B, C, and D as this 11, 5, 7, and 2. Predict the nature of the solutions. So you have to tell the nature of A, B, C, and D. So what is the nature of A?
Basic.
Basic, sir.
Ba-
Okay, A is basic. What about B?
Acidic.
Acidic.
Acidic. C,
Neutral.
Neutral.
neutral. Okay. Then D,
Acidic.
Acidic.
Highly
acidic.
acidic.
Okay. Give the constituents of baking powder. So what are the constituents of baking powder? What are the constituents of baking powder?
Sodium, hydrogen carbon.
The baking powder, not baking soda. They are asking the constituents of baking powder. So it is baking soda and a mild acid. Baking soda and a mild acid, they form the baking powder. And your baking soda is NaHCO3. So we'll be writing this way. The constituents of baking powder is baking soda and a mild acid like like tartaric acid can be used. Why cake or bread swells up on adding baking powder? Yes. Why cake or bread swell up on adding baking powder? Yes. Can anyone answer this? Why cake or bread swell up on adding baking powder? Ayunija, Siddharth.
Sir, because of the carbon dioxide that liberates.
Yeah, because of the due to the formation of carbon dioxide due to heating of baking soda. Okay, or when the baking powder is heated, carbon dioxide gas is liberated and hence it swell up. So also write the reaction. So what will be the reaction? Try to write down the reaction, everyone. All of you write down the reaction. I may check all at once. So just write down the reaction for this process. Write down the reaction for it.
Sir, can you repeat once?
Uh, Write down the reaction for this process. Yeah, you have the question.
Baking soda, wait, the fourth one.
Yeah, write a chemical equation. Why? Third, second part.
Okay, sir.
Okay, so have you written down the reaction, everyone?
Yes, sir.
Okay, so just show it. Show your reactions. All of you show it. All of you turn on your camera and show the reaction that you have written. Okay. Good. Anyone else? Anyone else who has done the reaction? Okay, no issues. Okay, let's see. I'm showing you the reaction. Horia, have you written the reaction? Okay, Siddharth has given the reaction. Got it. Okay, see. I'm showing you the reaction. The reaction is you have to heat NaHCO3. So when sodium carbonate is heated, it forms Na2CO3, sodium carbonate, plus carbon dioxide plus H2O. To balance this reaction, you have add here two. The next one is a white colored powder is used by doctors for supporting fractured bones. Write chemical name and formula of the powder. So, what is the name of the powder? Yes, be active. Write chemical name and formula of the
Sir,
powder. Yes.
PSO4 half. No.
Chemical name. What's the chemical name? First tell the chemical name.
Calcium sulfate hemihydrate.
Which one?
Calcium sulfate hemihydrate.
Yeah, chemical name is calcium sulfate hemihydrate. Very good. And its formula is,
PSO4 half H2O.
yeah. When this white powder is mixed with water, a hard solid mass is obtained. Write the balanced chemical equation for the change. So if you add water to it, you have CaSO4 dot half H2O. And if you add water to it, which is 3 by 2 H2O, so you get CaSO4 plus CaSO4 dot 2 H2O. Got it? Now, explain the action of dilute hydrochloric acid on the following chemical equation. So first one is magnesium ribbon. What would happen by the action of dilute HCl on magnesium ribbon? Dharya?
Sir, can you
Dharya?
once show the before previous?
Just answer this question and I'll show it. Answer this. Explain the action of dilute hydrochloric acid on the following with chemical equation. So what will be the action of dilute HCl on magnesium? Yeah, what is the action? What happens when magnesium ribbon reacts with dilute HCl? Dharya, are you able to get it?
Yes, sir.
Okay, so answer it.
1 minute.
Okay.
Sir,
Yes.
the reaction of dilute hydrochloric acid with magnesium ribbon will produce magnesium chloride and hydrogen gas.
Okay. So just write down the balanced reaction. I will be checking the balanced reaction.
Okay, sir, 1 minute.
Then sodium hydroxide. Huria Ishak, write down the reaction for sodium hydroxide. What are the products that I will get? Yeah, Huria Ishak.
Just a minute, sir. Can I send you in chat? I can't keep my mic unmute for long.
What happened, Huria? Are you able to answer this? Okay. Anyone else? Rijwana.
Sir, first answer.
Okay. Okay, Huria, please send it. Yeah, Rijwana, can you answer the reaction with crushed eggshells?
Yes, sir.
See, if you have crushed eggshells contain calcium carbonate. So let the reaction of calcium carbonate with sodium hydroxide. Got it? So with HCl. So this
Sir,
will get as
CO3
yes.
plus 2HCl gives
Okay.
rise CaCl2 plus H2O plus CO.
Okay, H2O plus U. Right. We'll do just one more question. Question B1. Dry pellets of see, dry pellets of a base X when kept in open absorbs moisture and turns sticky. The compound is also formed by chlor-alkali process. Write the chemical name and formula of X. What is the chemical name and formula of this?
Sir, chlorine.
Okay, which substance is this? Dry pellets of a base X when kept in open absorbs moisture and turns milk sticky. So maybe this is not helpful to you. You are not aware of these things. But if you read the next line, the compound is also formed by chlor-alkali process. Okay. So
Sodium
during the
hydroxide.
yeah, it is sodium hydroxide. Now you are clear. It is sodium hydroxide because it is the only base which is formed during this process. So it is sodium hydroxide. Then write chemical name and formula of X. So chemical name is sodium hydroxide, formula is NaOH. Describe chlor-alkali process with balanced chemical equation. So in the balanced chemical equations, you will be writing down reaction at cathode, reaction at anode, and inside the solution. Then what is the type of reaction occurs when X is treated with dilute HCl? Yes,
The neutralization reaction.
neutralization is okay. Okay, so bye all of you. See you again in next class. I hope you'll try to do these questions. I'll be adding this in wise. You can do these questions. Okay. Okay. Bye all of you.
Bye.
Right.